This is the video solution to practice problem A that accompanies sample problem 1.6 in your text. This problem appears on page 19. This question essentially asks us to use significant figures as a tool for rounding answers to problems correctly. This is the reason that we learn about significant figures in a course like this. The rule for using significant figures in multiplication and division problems is pretty straightforward. Our answer can only contain as many significant figures as the measurement with the fewest significant figures. There are two key words in this statement. They are measurement and fewest. A measurement is different from an exact or counted value, and we'll have to keep that in mind as we look at problems. And remember, we will want to round our answers to reflect the fewest significant figures when we multiply and divide. For addition and subtraction, things change a little bit. When we add and subtract, our solution has to be rounded so that it shows uncertainty in the highest decimal place based on the measurement with uncertainty in the highest decimal place. Notice that the words significant figures do not appear anywhere in this rule. So there are two different rules here, and we'll need two different mindsets towards significant figures as we look at any problem in this course. Exercise A gives us two measurements to add, 105.5 liters and 10.65 liters. Let's take a look at where the uncertainty lies in each of these measurements. The measurement 105.5 contains uncertainty at the last 5. It's been highlighted here in green, and this is at the 10th decimal place. The measurement 10.65 liters has uncertainty at the 5 as well, but in this measurement that uncertainty occurs at the 100th decimal place. If we were to think about doing this addition longhand, we would line up the decimal points and start adding the columns, right? We all know that it is much easier to plug measurements into a calculator and find the solution that way, but the calculator cannot and will not ever be able to round correctly for us. The sum of these two values is 116.15 liters, but the measurement with uncertainty in the highest decimal place is the 105.5 liters, where the uncertainty occurs at the 10th place. We will need to round our solution so that we show all values, including the rounded value at the 10th place. We're essentially going to have to round off of 5, and since we have a digit that is greater than or equal to 5, we will round this value up to 116.2 liters. Notice that as I report this final value, I always include the units associated with it. Exercise B asks us to carry out the subtraction 81.058 meters minus 0.35 meters. Can you tell right now which value has uncertainty at the highest decimal place? The value 81.058 meters has uncertainty in the thousandths place. The value 0.35 meters has uncertainty in the hundredths place. Of these two values, the value with uncertainty in the highest decimal place is 0.35 meters. Here, the uncertainty is at the hundredths. We can fish out the calculator now and run through the subtraction and find the difference on the calculator as 80.708 meters. Our decimal argument here leads us to believe that the rounding should occur between the 0 and the 8 shown in green. Since 8 is greater than 5, we will round up, and the solution to this problem will be 80.71 meters. Letter C is an excellent problem that asks us to add two numbers in scientific notation. Let's examine this one very carefully. In the first value, the 1 is uncertain. The 1 actually occurs in the 19th place above the decimal point, which you could tell if you were to write this value in decimal form. The value 1.228 times 10 to the 19th atoms has an uncertain 8. This 8 occurs at the 17th place above the decimal point. Here's how you could visualize that by writing the number in decimal form. This means that the highest decimal place with uncertainty is the 19th decimal place. Now we can use the calculator to add. My calculator says that the sum of these two values is 3.81328 times 10 to the 21st atoms. Rounding this value to the 19th place means that we will round between the 3 and the 2 shown in green here. 2 is less than 5, so we will leave the 3 alone and have a final solution of 3.813 times 10 to the 21st atoms as our final answer. Letter D requires us to shift gears and think about multiplication. Remember that the rule here revolves around the fewest significant figures. The measurement 1.255 decimeters contains 4 total significant figures. All of the digits are non-zero, so all are significant. The measurement 25 decimeters contains 2 significant figures based on the same reasoning. This is the measured value with the fewest significant figures. So when we round our answer, we will need to round it to have 2 significant figures. Doing the required multiplication on a calculator results in a product of 31.375 decimeters squared. Rounding to 2 significant figures means we will round between the 1 and the 3, and we will end up with a final answer of 31 decimeters squared for this one. Notice that the units on the final answer are decimeters squared, and that comes from the multiplication of decimeters times decimeters. The final exercise in this problem asks us to divide 139 grams by 275.55 milliliters. This is division, so we will focus on total significant figures again. The measurement of 139 grams contains all non-zero digits, so there are 3 significant figures here. The measurement 275.55 milliliters contains 5 significant figures by the same reasoning. As we look toward the solution in this one, we will round our answer to show 3 significant figures, the same as the measurement with the fewest significant figures. The calculator says that 139 grams divided by 275.55 milliliters is 0.504446 with some other digits after that. The units on this value would be grams per milliliter. Rounding this value to 3 significant figures means that we will round between the first 4s that appear in the value. This will leave us with a final answer of 0.504 grams per milliliter, and that's actually a density value. Here's a summation of all the answers that we just established for this problem. We didn't have to do too much rounding up at the end, but remember that we round up when we have a digit that is 5 or greater. And at this point, you should take a moment and do practice problem B on page 19. You can check your answers with the answers that appear on page 33 of your text, and let your instructor or your tassel leader know if you have any questions.